Hey guys, want to make you a short video on how to use Desmos for normal distribution. So this will go hand in hand with lesson 2 of our normal distribution very short chapter. So this was one of the slides that I went over in the PowerPoint for lesson 2, but in the video lesson already in Canvas, it just shows how to use a graphing calculator to do this. So I'm going to show you how you can do the same thing on Desmos for those of you who don't have access to a graphing calculator. So let's just start by going to Desmos. So if you just go to desmos.com, click on graphing calculator. We need to get the normal distribution function in here. So if you open up the calculator that's in the lower left corner, go to functions. It's going to pull up this menu and we're going to click on distribution. So within distribution, you are going to see this guy right here, normal dist, obviously normal distribution. So all you got to do is click on that, and it kind of gives you the prompts on what needs to go into these parentheses. So it needs to know what the mean is and what the standard deviation is, and both of those will always be given to you within the problem. So take a look at the one that we're doing right here. So this one says, talking about the light bulb, says the mean is 2800. Standard deviation is 450. So I'm going to put in the mean of 2800, comma, my standard deviation is 450, and then I'll close my parentheses, and that's all the information that is needed. So when you click on this box right here that says find the cumulative probability, now it's going to ask you what is the minimum and maximum values. Let me show you the graph. If you click on the little zoom fit link right here, it'll give you the normal distribution graph, which is kind of cool. And all the details to that I went over in the lesson video that's already in Canvas. But the main thing that we're doing with lesson 2 here is trying to come up with a percent or a probability of this distribution function. So the little CDF right here, that's cumulative distribution function. So we're looking for a percent or probability. For as far as the min and max goes, that will be guided by the question. So look at part A. Part A said find the percent, right, or probability or percent of light bulbs that have a lifetime of less than 1950. So if we wanted to say less than 1950, so 1950 would be about here on the graph, right? So in other words, we want this area right here. I need to know what is the percent of the graph within this area of the curve. So everything that is less than 1950. Well, the two things that your calculator needs to know is the minimum and maximum. If I just said less than 1950, well, everything below 1950 keeps going on forever and ever and ever in the negative direction. So our minimum for this question would be negative infinity. And you don't have to type that in, that's the default that's already there. So the maximum would be the 1950, right? So if I'm just typing in the 1950, so, and you'll notice what's kind of cool about it is it actually shades the graph for you, and it tells you the percent or the probability of that shaded area of the graph. So I can tell by this that this would be 2.95%. Right, if I wanted to change that to a percent. You can write that as a decimal. You can just say 0.0295, and that's accepted. So that's the first part. So let's change the question. So what if it said find the percent of light bulbs between 2300 and 3500? So if we were going to say between 2300 and 3500, those become your min and max. So between 2300 and 3500, and there you go. So my minimum is 2300, my maximum was 3500. So again, really neat that it shades the graph for us. And then it also tells us the percent of that graph that was just shaded. So about 80.7% in terms of percentages. So anyway, really cool feature, really easy to use. Let's do one more. So part C says more than 3,800. More than 3,800. So when we say more than 3,800, right, now that means I'm going to start at 3,800, which would be about here, and I'm going to head off to the right. So if we just said greater than 3,800, right, that means 3,800 is our minimum. And then what would be our maximum? Right, so if I'm heading off forever to the right because it just said greater than 3,800, well, if I'm going to the right forever, that just means I'm headed towards positive infinity, right? And so, again, if you just clear this out, infinity is the default. It will automatically be there for you. You don't have to type that in. So it's already there. So all I did was clear this out, and the infinity pops up. So you can see that it was shaded. One of the things that's really nice about the shading is it gives us a great visual of the area of this curve that you're trying to find, right? So when we say more than 3,800, automatically I should be thinking, okay, that's 3,800 and then to the right. And that's exactly what's got shaded, so that's kind of confirmation that I put in the correct information here. Here's our percent. This would be about 1.31%. So obviously very, very tiny, and you can see that makes sense because it's a very small shaded area of this graph. Let me give you one more idea. The other type of question that came up in the lesson for today is our expected number question. So this is the one that says, okay, we're going to go one step further than the percent. And now we want you to actually tell us how many light bulbs this would apply to. So it says right here that they tested 120 bulbs. So how many of those bulbs would have a lifetime less than 2,000? Less than 2,000. So if I said less than 2,000, again, that means I'm here at 2,000, and I want everything below that shaded. Everything to the left. So in other words, the farthest left I can go is negative infinity. And again, that's automatic. My maximum is 2,000 because I want everything below 2,000. Right, so here's what it does. It shades the area, just like we've already been doing. It tells me the percent, but here's the extra step, right, is when you get the expected number question, you have to take your percent and multiply it by the amount of light bulbs that were tested, right? So if we want to know how many of these light bulbs are expected to be less than 2,000, well, according to this information, only 3.78% of those bulbs are going to have a lifetime less than 2,000. So I need to take this decimal and multiply it times 120 in order to get this answer. You can see that's what they did down here. They said, let's take the percent and multiply it by 120, and this is how many light bulbs we're referring to. So anyway, that's how you do normal distribution on Desmos. So I hope that helps you.